Thank you very much, James. And next up, we have Robin Nissan from SERDP ESTCP. So Robin manages several of the efforts there at SERDP and ESTCP on environmental elimination and so forth.
There doesn't appear to be any activity in this meeting. If you would like to stay on the line until others join, please press 1. If not, I'll end the meeting.
Is anybody else hearing that?
Right now.
Yeah, so Robin.
Okay, so I'm waiting for the view graphs to come up. While that's happening,
they're up on my side.
Can you guys hear me? Just one person say yes. I'll keep.
Yes, I can hear you, Robin, and the slides are up. Okay.
Yeah, I see them now. So fantastic. So SERDP and ESTCP, I'm going to give an overview of who we are. Many of you have heard this before, but it's going to be a pretty quick overview, and then I'm going to talk a little bit about some of the projects that we've funded over the years, going back, probably almost 10 years. SERDP is a science and technology, I should say this, we're both in OSD in the sustainment group and the environmental group, as was mentioned. SERDP is an S&T program. We're statutory. We're a partnership between DOD, DOE, and EPA, and we're looking for basic and applied research, fundamental research, but also advanced development. In the ESTCP program, we're looking for demonstration and validation, looking for improved cost, both energy technologies as well as some things in the weapon systems and platforms area. We want to transition things out of the laboratory and show that they actually can work in a military environment. We want to partner with the end user and regulator, so we want to make sure that the thing has wheels and can continue to move on, and accelerate commercialization. This is kind of an overview of what we do. I kind of said most of this, but we start looking at what the service requirements are, what basic and applied research needs to be done, advanced development to get to the point where we're ready to demonstrate and validate a technology, and ultimately look towards implementation. We show this linear, but I'll tell you what, it doesn't always happen that way. So sometimes we come in at different points on this graph. Program area structure. My area is weapon systems and platforms. But also within SERDP and ESTCP, we have an energy and water program area. That's ESTCP only. We have environmental restoration, both SERDP and ESTCP, munitions response, finding things like that, either underground or underwater. And that's also both SERDP and ESTCP. And finally, resource conservation and resiliency. And again, SERDP and ESTCP. So we're a very small group. We have 5 program managers, 1 director, and some support from Noblest. So what we're trying to do in my area, enhancing material availability has become very important. One of the reasons is we have some big problems. Corrosion is a $20 billion per year problem within the DoD, and it has impacts across the board. So if we can help fix this, we can reduce the cost here. So we're looking for alternative technologies. We're looking for better ways to understand and predict life cycles, material lifetimes, I should say. We're also looking at sustainable processes. So additive manufacturing is one of the areas we're looking at. And moving forward. So within my program area, weapon systems and platforms, regulatory problems are some of the things we're worried about, working with the European Union and others, but also EPA and industrial hygiene. So heavy metals, and of course a lot of what we're dealing with in this area is heavy metals, and we want to get rid of some of them like chrome, cadmium, lead. Solvents are a problem, and emerging contaminants. So all of these are potentially problems, and we're trying to mitigate against them and minimize their use. So we look for things that we can do within the shipyards and depots and the OEMs. We are looking for sustainable ingredients, alternative manufacturing processes, other things like emissions of from diesel engines, gas turbine engines, jet noise, blast noise, firefighting. So all of these are areas that we're concerned with and consider to be problems that we can address. Just to point out what we're dealing with on for instance, a military jet, this F-18, and you can see cadmium, hard chrome, soft chrome, conversion coatings, primers. It's a lot to deal with, and a lot of stuff going on that can be addressed or perhaps needs to be addressed. Over the years, we've invested a lot in surface engineering, and going back 10 years, we're spending between $4 and $7 million a year on these kinds of issues. Again, cadmium and chromium, paints, composite materials, coating removal, and down here surface engineering. So you can see this is what we spend both in combination of SERDP and ESTCP. So how do we do this? Well, we have a technical committee on the SERDP side. We have a technical committee that comes in and helps us to develop statements of need. What do we need to do? What are the things that are eating our lunch? And we put out calls once a year. The calls go out in late October. Pre-proposals are due in January. Full proposals come in March. We then go to peer review. So these actually go out to scientists in the area to help us decide what has scientific merit. Then we come back to the technical committee and do a check to see if it's an important DoD problem that we should be dealing with right now. And we make a selection in July, and we get approval hopefully in the September-October timeframe and move forward. That's the SERDP side of the house. On the ESTCP side, it's a little bit different because we're not statutory. We can do things a little bit different. But I would say that on the ESTCP side, one of the important things is it really, from my perspective, needs to be done in a military environment. So we want to do things that are actually going to make it there. In the November-December timeframe, we develop topics. Again, we put out a BAA and a federal call for proposals. We get pre-proposals in March. Request full proposals and get them in July. They go to our technical committee for a relevance check, and we make a selection in the September timeframe, and at that point we need Assistant Secretary of Defense or Deputy Assistant Secretary of Defense approval. Okay, so real quickly now, what are the projects that we've done over the course of time, and what's the level of success? And it's really difficult to do this in 10 or 15 minutes, but I talk really fast. So we had a project that started probably in 2006, if I'm correct in my assessment of WP 200620. And that was really dealing with the repair of magnesium aircraft components. And in 2012, we said this is our project of the year. And that's because over that period of time, it was demonstrated not only that it was effective, but that there were some repairs that could be done that were saving the government significant dollars. And this benefit to cost study was done in 2015. So that's quite a while ago. 5 years ago is when that was completed. And at that time, there were 13 approved repairs for aluminum on magnesium. And the cost savings per year at that time were estimated to be $23.6 million to continue for approximately 20 years. Reason is we were dealing with very high value parts, as has been discussed by previous speakers, parts that had long lead times. And so there was, that amount of success is significant and something we can take to the people who give us our money and say, we are having an impact. And I would say that based on everything I'm hearing today, and I can't, SERDP and ESTCP can't take full credit for it, but we can certainly say that we invested early and got some things done that did prove out the technology and show that there was great potential. So from that success, we move on, and now story number 2 is a SERDP effort that began in 2017, I believe. And here we started looking at looking for chrome and nickel plating replacement. And the project that we initiated was looking at powder morphologies and modeling various powders and how they would perform and what they would do on a surface. It also looked at optimizing spray processes, and I think they did some novel work as well, although I'm not quite sure whether SERDP paid for that or whether it was paid for by Army. It gets a little hazy, but I'll take full credit and say we did it all. But the ultimate achievement was a nickel process was developed that had greater than 400 Vickers hardness, and a chromium alternative yielded greater than 700 Vickers hardness. Based on these results at the SERDP stage, and that is, basically coupon work, and we want to take that to the next step and move on to things that are of interest to the DoD. And here we are now looking at the third project, an ESTCP project that is ongoing, started in FY19, and just basically says, okay, now that we've shown that we can do this, let's do it on some real systems and prove that we can get some structural repairs done. So here we're looking at design of cold spray nozzles for inner diameters. We're looking at powders that are now commercially available from Solvus Global, and we're looking for things that will improve impact and wear resistance. So we hope we think that that's going to be a very successful project and will yield a lot of additional success down the road. With that, I just have one last thing to say, and that is that our Assets Defense, a surface engineering workshop, is going virtual as well, and we hope we're as successful as CSAT has been. We're going to be doing this on August 4th through 6th, and if you go to that website, you should be able to find it and maybe participate and listen to some talks in the areas that we are discussing. So with that, I am done, and I'll be glad to answer any questions.
Thank you, Robin. And there's a question that came in regards to the REACH program in Europe, and if SERDP is connected to that particular effort, and if so, how?
So there's some people in my office who are very, very involved with REACH and talk to folks, and we have meetings about it. And the bottom line is, the global economy we live in, everything we do, we need to be looking across the border and understanding if there's an impact. So, from the perspective of if we were just looking at what we can do in the United States and we start using something that has implications for use in Europe, we need to understand that going forward. So we can't just do things on our own and assume that we're going to be able to do repairs in the EU and not have taken into account what they're doing. So Keith Legg is a subject matter expert, and we listen to him, and he pays attention to what's going on in the EU. And so when we are using materials that potentially are being regulated, we pay attention.
Right. Very good. One more question. In regards to electrolytic chrome plating replacement, my career goes back close to 40 years, and when I first started, there was big funded efforts, as you well know, because you were around too, to mitigate the use of cadmium plating,
yeah.
And that took over 20 years.
And we had a few steps along the way. So we went to IBD aluminum, and now it seems like zinc nickel is kind of making the grade, if you will. So
so if you had your
go ahead.
Yeah. So if you had your crystal ball, what do you think when the EPA and finally says no more chrome? Is that going to be in 5 years, and 10 years, and 1 year?
I think it's not going to be elimination, but it's going to be harder and harder. So the real issue, I think, is things like what ACGIH is doing. So when the industrial hygienists start, and TSCA and EPA, when they start saying these are the limits, and OSH too, when the limits go so far down that you can't stand, and I mean, you know, the problem we have going forward is that everything that we have that's legacy has chrome on it. So we start sanding things, we're going to get dust. My crystal ball tells me we got to keep on moving forward and trying to do the best we can. And you know, even things like JSF, the new aircraft that are coming out, they got a lot of chrome on them. So ultimately, as we're doing repairs, we need to figure out ways to do those repairs without producing a plume of dust and potentially, you know, putting things into place to help us clean it up as we do it.
Okay, I appreciate it. Thank you very much, and it was a great talk.